Good morning, ladies and gentlemen. We are going to do 8.3b today. We're just going to do a little bit more work with graphing our rational expressions. Our objectives are to do a few more examples where we have to find the asymptotes, both vertical and horizontal. And then I'm going to show you a few more examples of our slant asymptotes. Okay? I have some definitions written out already. So remember that a slant asymptote happens, and it looks really cool on your graph, when the degree of the numerator is higher than the degree of the denominator. Okay? And then the actual slant asymptote equation comes from the quotient, which is the answer when you do long division. All right, so here is, I'll put it right back, our first example. Okay? So notice that the degree in my denominator is 1. The degree in the numerator is 2. Therefore, the degree in the top is higher, so I'm going to need to do long division. All right, so I'll do that kind of down here. So I'm going to divide 3x into x squared minus 5x minus 36. We've done this already this year. Okay? X squared divided by 3x is going to be x over 3. Ugh, that's yucky. Okay? When I multiply through, I'm going to get x squared, change the signs, okay? And then I'm going to subtract, so I'm going to get a add negative 5x, and I'm also going to bring down the 36. A negative 5x divided by 3 is going to be a minus 5/3. I know those are kind of yucky numbers, I'm sorry. So when I multiply through, I'm going to get, oh sorry, I didn't need to bring this down yet. I'm looking at my work going, what did I do? Okay, I don't need to bring that down yet. So I'm going to get a negative 5x, divide, and I get a positive 5x, change the signs, okay, so now it's positive, and I'm going to get 0. And then I can bring down the 36. All right, well I can't divide 36 and 3x, so that means that this is my remainder. Okay, so I would do plus a negative 36 over 3x, and this is my quotient. Okay, so that's actually going to be my slant asymptote. Okay, so I'm going to write y is equal to 1/3 x minus 5/3, and that's going to be my slant asymptote. Okay, and I'm just going to show you, I'll put it right here, sorry, that I can rewrite the original expression to be y is equal to the quotient. So I'll put my remainder first, a negative 36 over 3x, and then plus, and then I'm going to put my quotient, minus 5/3. So this is the remainder, we'll call it r of x, and this piece is the quotient, we'll call it q of x. Okay? This quotient is my slant asymptote. So now if I graph this, okay, so if I go back and look at my original equation, sorry, I was looking at my work thinking, what do I need to do next? The first thing that I need to do is graph my numerator, factor my numerator. So I'm going to have x minus 9 and x plus 4, because 9 and 4 is a negative 36, and 9 minus 4 is going to give me the negative 5 over 3x. Okay. I am going to have I'm not going to have a horizontal asymptote. I have a vertical asymptote at x is equal to 0. So I'll write it over here. Vertical asymptote is x is 0. Let me scoop my paper up. My horizontal asymptote, there's not one because I can't have a horizontal and a slant. And then my slant asymptote is going to be y is equal to the 1/3 x minus 5/3. So the numbers are a little bit weird, and they shouldn't always be that weird, but let's just go ahead and manage this. So this is x is equal to 0, okay? And then if I graph this, negative 5/3 is 1 2/3, so if I go right there, that's going to be my y-intercept, and then up 1 over 3, okay? So then I'm going to have, and I'm not actually going to be too precise on this one, but I'm just going to show you my graph. Remember, asymptotes always have dotted lines. So there's my asymptote. I have one here at x is equal to 0. So my curves are going to actually look like that, and then they're going to look like that. So kind of cool. So that would be my graph. All right, so let me do several more examples for us. Okay, so I'll do one that's not quite as weird, with weird numbers. All right, so I'm going to do another one with a slant. So I'm going to have f of x is equal to x squared minus 25 over x minus 4. So I am noticing that the degree in the top is higher, so I'm going to do my long division. So this one I can actually do synthetic because it's a linear factor. So I'm going to divide by a positive 4, and I'm going to divide into 1x squared, 0x, and a minus 25. Remember, when you do synthetic, you always have to put placeholders in. So 4 times 1 is 4, add. 4 times 4 is 16, and subtract, and I get a negative 9. So I could rewrite, this is my quotient, and this is going to be x plus 4, and this is my remainder, and that would be a negative 9 over x minus 4. Okay? My equation, this is my slant asymptote, because remember, it's the quotient. So if we had been doing long division and dividing by x minus 4 into x squared minus 0x and then minus 25, up here on the top I would have gotten x plus 4. That would have been my quotient. So that is my slant asymptote. Okay, so if I go ahead and finish, I'm going to factor the top, x plus 5 and x minus 5, and then in the bottom I had x minus 4. So I know that my vertical asymptote is going to be x is equal to 4. I know that my slant asymptote is going to be y is equal to x plus 4. Now I'm going to use the numerator to help me find the zeros, or the x-intercepts. So my x-intercepts, where it crosses the x-axis, x is going to be equal to plus or minus 5. So now I can put all that information on my handy-dandy graph. So I have a vertical asymptote at 1, 2, 3, 4 at x is equal to 4. So I'm going to draw that on my graph. Okay. I have a slant asymptote at y is equal to x plus 4. So 1, 2, 3, 4. There's my y-intercept, and then I'm going to go up 2 over 2. I do that so I can spread my points out a little bit, connect my dots. So this is y is equal to x plus 4. And then I have 1, 2, 3, 4. This is a negative 5, and this is a positive 5. We found that my x-intercepts were at a negative 5 and a positive 5. So now I can draw my graph. Oops, I missed my dot, sorry. And this one. So there's my cool graph. Alrighty, I have another example for you. I just have several today. Actually, this is my last one. I lied. Nice short video. Okay, our next one, f of x is equal to 2x squared over x squared plus 5x plus 4. So a couple of things to notice. The degree is the same, top to bottom, second degree, second degree. So my horizontal asymptote is going to be y is equal to 2 divided by 1. So I'm going to have a horizontal asymptote at y is equal to 2. I need to rewrite and factor, and I'm going to get x plus 4 and x plus 1 in the denominator. That factoring process just keeps sticking around forever. My vertical asymptotes then, which always come from the denominator, are going to be x is equal to a negative 1 and x is equal to a negative 4. Okay? If I look at my numerator and solve that, if I set 2x squared equal to 0, I'm going to get x is equal to 0. That's going to be my x-intercept. So now let me put all this information on my graph. This one's a little bit more complicated, and so I'll verify everything in my grapher. Okay. First things first, I'm going to graph my verticals. So I know I have one at a negative 1. Okay, so I'll put that on there, and then 2, 3, I had another vertical asymptote at a negative 4. My horizontal asymptote was at y is equal to 2. Get that 2 on there. Remember, you always have to label your graphs well. And then I know that it crosses at x is equal to 0. Okay? So this one's actually an unusual case. So let me put this in my grapher and then I'll explain it to you. All right, just checking to make sure those guys are off. Clear that stuff. All right, so if I enter my equation, I'm going to enter 2x squared divided by parentheses x squared plus 5x plus 4. And I have noticed when I watch some of you use your calculators in class, this is your variable button. You do not need to do alpha and then do x. That's kind of a waste of time. You need to use your variable button. It helps you, or it puts your variables in your equations. Alrighty, so then if I do a zoom 6 to look at this little guy, there's that piece, and then this is where we have an interesting situation. So let me transfer that information to our graph. So in this section right here, here's this curve. And then in this situation down here, I have a weird little chunk of my curve. Okay. And then up here, I actually have an unusual situation. Okay. So notice that, and I put open circles there, my graph actually goes across this horizontal asymptote, but it creates a hole at that point. So since it's crossing my horizontal asymptote, I actually have to put a hole there because at that point, the y values are undefined. Alrighty, so pretty cool looking graphs. Alright, let me give you your problems, and then this one's done. So a nice short video for today, just a little bit more practice with this process. Okay. So I want you to sketch the graph. You need to find all asymptotes, whatever kinds they happen to be, and you need to find your x-intercept. So remember, that's going to come from solving the numerator. All right, and then you need to find your y-intercept, if there are any. There's not always one, and that comes from letting x equal 0 and solving for y. So those usually turn out to be pretty simple calculations. All right, your first problem, f of x is going to equal 5x squared plus 7x plus 2 over 2x squared minus 8. Okay. Your second problem is going to be f of x is equal to x squared minus 3 over 2x squared plus 5x minus 12. Okay, and that's all you have. You just have the two problems. So good luck with those. Make sure that you label your graphs really well, and then I will see you in class tomorrow.